and welcome to your first video lesson of the semester. All right, Algebra 2, let's get this thing going. So today we're just going to get really refreshed on some things that you probably learned in Algebra 1. But hey, let's warm up, let's get those gears greased up and moving. So here we go, we have some vocabulary we want to talk about. An example of an algebraic expression, right? And this looks like that has some variable quantities in it. We also call it a polynomial. All right, so each one of these things we want to talk about terms, right? 5x cubed is a term. Also 9 is a term. These are terms of this particular algebraic expression. All right, you're always going to write these polynomials in descending powers of x, right? So we start with x to the third power, and then the next term is x to the second power, or x squared. The next term, we have negative x. That's actually to the first power, right? And it turns out that there is actually an x associated with that 9. Right? It's just x to the 0 power, but x to the 0 power is 1, right? So it's 9 times 1. So they are actually in descending powers of x. You guys know about coefficients, right? The coefficient of x cubed is 5. The degree is 3 because x has been, our variable x, has been raised to the third power. Hey, the degree of this polynomial is going to be the highest degree of any non-zero term, which is all of the terms in this particular expression. So we're going to say that this is a third degree polynomial because you can see that term 5x cubed, that has the highest degree, right? The highest exponent in this expression, which is 3. All right, the polynomial 7n to the 6th power, it only has one term, so we're going to call it a monomial. So any expression that only has one term, we'll call it a monomial. And we have some other examples of monomials down below. A binomial, right? Bi means 2. Refers to a polynomial that has exactly 2 terms. We have some examples down below here as well. Tri means 3, right? So a trinomial is going to refer to a polynomial with 3 terms. No problem. All right, we're going to add some polynomials. So we're going to combine like terms. Let's do an example. All right, we're going to add these things. So it looks like I have some like terms. M cubed and 2m cubed are like terms. So I'm going to add those. All right, what is 2m cubed plus m cubed? Well, what we're going to do is we're going to leave our exponent the same. And we're going to add our coefficients. So this one, even though it doesn't have a 1, remember, there's like an invisible 1 in front of my m cubed. So that means I'm going to add 2 plus 1, and I'll wind up with 3m cubed, right? I also have some like terms here. Negative 9m squared and 3m squared are like terms. I'm going to add those together. So just on the side, right? What I'm really doing is negative 9m squared plus 3m squared. I'm going to add my coefficients. Negative 9 plus 3 is going to be equal to negative 6m squared. So, negative 6m squared. And I'm just taking it real slow, showing you the little in-between steps. You don't have to do that if you have a good handle on this. Hey, there are no other m terms, right? So that 5m cannot be added to anything in there, right? In other words, there are no like terms. 5m has no like terms in this expression. So I'm just going to drop it down. Now these guys right here, right? These are my constant values. And those are like terms. So I'm going to have negative 4 minus 1 is going to be negative 5. And that is our final answer. Fantastic. Let's do another one. So we're going to add 10k squared plus 2k minus 1 to, we're going to add it to 5k squared plus 7k plus 9. So I'm going to rewrite that so it says that. There we go. That's an expression that we can work with. Let's find our like terms. All right. 10k squared and 5k squared can add together, and that's going to give me 15k squared. 2k and 7k are like terms, so I can add those, and that's going to give me 9k. Negative 1 plus 9 is going to be 8. That's our final answer. There are no more like terms that I could add in that particular expression. All right, let's subtract polynomials. Remember, when we do that, we need to use the distributive property when we have a negative sign outside parentheses. In other words, it's like, again, I have this imaginary one, or not imaginary, my bad. It's invisible. They literally call it invisible. That's the technical term for it. I'm going to distribute it, right? So it's essentially like I'm multiplying each term by negative 1. So I'm going to go ahead and write that expression, or rewrite it, just the exact same thing that we have up in our original problem. All right, I'm going to drop down my 8x plus 3. There's nothing I need to do with that because I don't have any number of multiplying this, right? I don't have any number sitting outside of my parentheses. However, this negative sign, like I said before, it needs to distribute. So negative 1 times 5x is going to be negative 5x. And negative 4 times negative 1 is positive 4, right? So essentially what that's doing is it's changing the sign of everything inside my parentheses. Okay, cool. Now, do I have some like terms that I can combine? I sure do, because I can combine 8x and negative 5x. I'm going to add those coefficients. So 8 minus 5 is 3, and that's x, right? And now I also have the like terms 3 and 4. I'm going to go ahead and combine those. So 3 plus 4 is going to give me 7, and that's done. All right, just a little bit of a procedure, right? So just like I said, you're going to be changing the sign of everything inside of your parentheses when you distribute that negative 1. Let's go ahead and subtract again. We just did this one. I'm going to do it again. So remember, I'm going to change the sign of everything in my parentheses because I have to distribute this negative sign here, right? I'm When I combine like terms, 8x minus 5x is going to be 3x, and 3 plus 4 is 7. It says subtract it vertically. We're just going to go ahead and subtract. So the first thing that we do when we are going to subtract is distribute that negative sign. I don't have anything that needs to be distributed, so I can just break out this first expression that's in parentheses. I can just break it out of the parentheses. This negative sign in front of the 2w squared minus 2w cubed minus 4w squared, and so on, right? That needs to be distributed. So let's go ahead and do that. What's it going to do? It's going to change the sign of everything in the parentheses. So that positive 2w cubed is going to become negative 2w cubed. The negative 4w squared is going to become positive 4w squared. And we're going to continue on with that, right? Changing the sign of what's inside the parentheses. But we're not done, because we always need to look and see, are there some like terms that can be combined? Yes, right? I got this one and this one. So I can combine negative 6w cubed and negative 2w cubed. So negative 6w cubed minus 2w cubed, right? What is negative 6 minus 2? It's negative 8. I can also combine these. All right, looking for like terms. My squared terms can be combined. Negative w squared plus 4w squared is going to be positive 3w squared. And then this 10w can be combined with this negative 9w. So 10 minus 9 is going to be 1. And if you want to put a 1 in front of it, that's just fine. But it's the same thing as 1w, right? What do we have there? Just 1w. It's assumed that there's a 1 out in front of that. In other words, it has a coefficient of 1. And then our last two terms that we can combine are the 1 and the 5. 1 plus 5 is 6, and we're done with that problem. Don't get too excited. All right, so if we're going to add and subtract polynomials with more than one variable, we're going to have to, again, combine like terms. We're going to have to combine something. Or find our like terms and combine them, right? I can't add x's to y's and y's to x's. Can't do that. So if we look at this, particular answer to B, that is what we're going to wind up with, right, for our answer to B. Cool, but how did we get that? Well, let's figure it out. Okay, I'm going to just throw this over. Well, I'll throw it down there. And you can go down there a little bit. And let's look at A. Let's actually calculate this. Well, B into 1 right. Let's do it. All right, so let's find our like terms in A. I'm going to go ahead and just rewrite this thing. We don't need those parentheses anymore. There's just a 1 sitting out in front of there, right? That invisible 1. And if I distribute a 1, it does nothing, right? Because 1 times 9a squared b squared is 9a squared b squared, right? Multiplying something by 1 doesn't change it. Just like 1 times 4 is 4. That kind of concept. So I'm just going to go ahead and break this out of these parentheses. And hopefully I don't run out of room. You got this. All right. Now let's identify like terms. In other words, I am looking for anything that has a squared b squared. If it has a squared b squared, I can add it to my first term. There's one. 9a squared b squared. So I can go ahead and add those two together. If I have 1, remember there's an invisible 1 out in front of this. If I have 1a squared b squared and I add it to 9a squared b squared, 1 plus 9, 10, and we don't forget that that's an a squared b squared. All right, so the next thing we're looking at is 2a squared b. I'm looking in this expression to see if there's another a squared b, and indeed there is. I have a negative 5a squared b. So I can add 2a squared b plus negative 5a squared b, which is the same thing as 2a squared b minus 5a squared b. They're the same thing. I can say plus negative, or I can just say minus. So 2 minus 5 is going to be negative 3a squared b. And that's it. I need to find an AB term in here. There it is. I have a negative AB. So I can add those two things together. Negative 13 minus, remember there's a little invisible 1 out in front of there, so I have negative 13 minus 1, which is negative 14. And remember, we're talking about ABs. And the last two terms that I can combine are my constants, negative 4 and positive 17. And that's going to give me positive 13. And there it is. Hey, let's see on your own as a little challenge. Can you arrive at this answer for B? Okay. Go ahead and work that out. Homework. We're going to do this in class. I'm going to have worksheet problems 1 through 10. We're not going to use a worksheet. I'll project those problems on the board for you. When I see you tomorrow, thanks for watching. Have a great night.